The core of the atom is bonded by the strong nuclear force fighting against the electrical forces between the protons. We can understand on some basic level the electrical forces, but what about the nuclear ones? How do we understand them intuitively? Well, we can imagine two towers, both being protons, for example. Now, imagine that in these two towers, there are people who want to communicate with each other. This communication, in our analogy, will be the bond in the atom core, which is the strong nuclear force that is holding it. Now, how can they communicate? For example, they can use a string or a rope, tie a bucket to it, and pull the ropes one to the other, one to one side, one to the other side, in order to take the bucket with a message inside of it to their tower. And that rope with that bucket with a letter inside of it is our bond. And the letter in the bucket is a pion, which is a meson, which is a particle composed of two quarks that are each other's antiparticles. There are basically two possible states in this situation. In quantum physics, we call them the base states. One where the letter is by the first tower, and one, of course, where the letter is by the second. But how could we make it so that the least energy is necessary to take the bucket for both of the towers? Well, the best possible way is to have the bucket exactly in the middle, so that none of the towers have to use more energy. This is actually what we call a superposition of these two states, where both have the same probability of happening, but in math, the pion is in both states, halfway in between. This is a special state of the system that we call a stationary state, what you also might know as an energy level. Of course, in real physics, there are as many energy levels as there are base states. So in reality, there are two energy levels, but we'll ignore the higher one for this explanation. That gives almost everything we need to build the bond, but where exactly is this force? We have the pion in the lowest energy level, we have the protons, so what happens now? Well, the energy of the system is the energy of both protons while separated, minus the energy A, that is also coincidentally, or in reality not, also an amplitude of probability of the pion going from one tower to the other. And the thing is that this energy A can also be explained in our metaphor as, for example, the frequency of the letter going back and forth between both towers, meaning that it gets smaller as the towers get further away from each other. That means that the energy of the entire system is smaller when they are closer together and bigger as they get further away. We also know from the definition of work that there is a force pushing these protons to each other to get to the lower energy state. And that's it. We did it. That's the strong nuclear force. Of course, this force balances at a certain distance with the electric force, and we have a stable bond. And the two towers can finally live in the perfect conditions for not so perfect and efficient way of communication. Thank you very much for watching.